All right, for our second problem, we're using the same equation because it says how many grams of nitrogen are needed to produce 30.6 grams of ammonia. So it's the same balanced equation we used up here at the top. And this time we're going to start with ammonia. We've got 30.6 grams. And remember, we can't go from formula to formula. We can't go from ammonia to nitrogen before we convert this to moles. So I'm going to move grams of ammonia to the bottom, moles on top. 1 goes next to mole, and next to grams, I'm going to put the molar mass of ammonia, which is what I calculated up here, 17.04. Now I can set up my mole to mole ratio. So I move moles of ammonia to the bottom, and I'm going to put moles of nitrogen on top. And the ratio of nitrogen to ammonia is 1 to 2, since there's not a coefficient in front of nitrogen. And then lastly, I just need to convert that back into grams. This time I'm using the molar mass of nitrogen. So that's 14.01 times 2, which is 28.02. All right, so now I'm ready to solve. .6 divided by 17.04 divided by 2 times 28.02. And I'm going to round this to 3 significant figures, so I get 25.2 grams of nitrogen. All right, moving on to problem number 3. All right, problem number 3, it says during a combustion reaction, how many grams of water will be produced from 52 grams of ethanol? All right, so this problem is great because it's requiring you to remember information you've learned from the past few units. If you remember back in our nomenclature unit, we learned about organic molecules. Ethanol is one of them. So remember, eth is 2 carbons. All tells you that this is an alcohol, so one of these carbons has an OH on it. And since this is ethanol, this is an alkane. So that just means that all of the carbons, all the other bonds that the carbons form are with hydrogen. And this is also a combustion reaction, so we know that combustion is when you take an organic molecule, combine it with oxygen to produce water and carbon dioxide. So I'm going to write this formula up at the top. That's C2, and there are 1, 2, 3, 4, 5, 6 H's, and then 1 oxygen. Plus oxygen yields CO2 plus H2O. So that's our combustion reaction. Now we need to balance it. So starting out, I see that I have 2 carbons, so I'm going to put a 2 here. I have 6 hydrogens, so I'm going to put a 3 here. Now I need to add up my oxygens. I have 4 plus 3, that's 7. So on the left side of the equation, I also need 7. I have 1 in my ethanol formula, so I only need 6 more, meaning I'm going to put a 3 in front of oxygen. All right, so now I have a balanced equation. Now I'm ready to solve the stoichiometry portion. So I always start with what I know. I have 52 grams of ethanol. And I'm going to first convert that into moles. So over to the side, I'll calculate my molar mass. I have 2 carbons. I have 6 hydrogens, and I have 1 oxygen. Adding all that together. I get 46. All right, so I'll put 46.08 next to grams and put 1 on top. And now I'm ready to set up my ratio. So it says during a combustion reaction, how many grams of water? So water is what I'm trying to find. I can't turn it into grams without first setting up my mole to mole ratio. So I'm going to put moles of water on top, moles of ethanol on the bottom. And remember where we're getting this ratio from? This is coming from our balanced equation. So next to water, there is a 3. And next to ethanol, there is nothing, which is a 1. Now I'm going to convert this back into grams of water. So finding the molar mass of water, 2 times 1.01, 1 times 16, equals 18.02. And now I'm ready to solve my equation. 52 divided by 46.08 times 3 times 18.02. And since my original problem, my original number had 3 significant figures, that's what I'm going to do for my answer, 61.0 grams of water. All right, one more problem from the slide. It says calculate the mass of iron that should be produced when 452 grams of iron 3 oxide reacts with hydrogen gas. So keep in mind that we have to start with a balanced equation. So let's read the problem again. Calculate the mass of iron that should be produced. So iron is going to be one of your products. Calculate the mass of iron produced when iron 3 oxide reacts with hydrogen gas. So iron 3 oxide, remember that 3 is a plus 3. Oxide is -2. So we cross our 2, we cross our 3. And we are reacting that with hydrogen. And one of the products of the reaction is iron. Now, they haven't told you everything, because as you can see, if we leave the equation like this, we are definitely violating the law of conservation of mass, because we don't have oxygen or hydrogen on the other side of the equation. So this is an example of a single replacement reaction where hydrogen took the place of iron. Iron is now by itself. So hopefully you can see that since hydrogen is taking iron's place, the product is going to be water. We know that hydrogen is with oxygen. Hydrogen has a +1 charge. Oxygen is -2. So that's how we get water from that. So now we don't need these charges. Let's go ahead and balance our equation. We have 3 oxygens on the left. So I'm going to put a 3 on the right. We have 6 hydrogens on the right. So I'm going to put a 3 in front of hydrogen here. And then I need to put a 2 in front of iron. So now I'm ready to solve, to set up my stoichiometry problem. I have 452 grams of iron 3 oxide. Remember, step 1 is to convert that into moles. So we're going to set up our molar mass calculation over to the side. 2 iron, 3 oxygen. Iron's mass is 55.85. Oxygen is 16. Now I'm kind of saving us some time and assuming you know where to find these masses from. Those are from the periodic table. 55.85 times 2 gives me 111.7. Here I get 48. So I get 159.7 grams. And now I'm ready to set up my mole ratio. So I move moles of iron 3 oxide on the bottom. I'm calculating the mass of iron. So I'm going to put iron, moles of iron, on top. That ratio is coming from my coefficients. So iron to iron oxide is 2 to 1. And then lastly, I need to convert grams or moles of iron into grams of iron. So that is 55.85. And I'm ready to solve. 452 divided by 159.7 times 2 times 55.85. And I get, again, I'm rounding to 3 significant figures, so I get 316 grams of iron. Now, in all of these examples, I've been converting grams to grams. Sometimes it's going to be a lot simpler than that. So I'm going to do one example of a very easy problem where you're not going to have to worry about molar mass. So we'll just do the formula for making water. How many moles of oxygen do you need to produce 5.5 moles of water? So first of all, let's write our equation. Oxygen plus hydrogen yields water. And to balance it, I need a 2 in front of water and a 2 in front of hydrogen. So starting with what I know, I have 5.5 moles of water. And I'm trying to solve for moles of oxygen. So notice, this is in moles, this is in moles. I don't have to worry about converting anything because it's already in moles. I can go straight into my mole ratio. So I move moles of water to the bottom, moles of oxygen on top, and my ratio is 1 to 2. So then to solve, I'm just dividing 5.5 by 2, and I'm done. So just keep in mind that you're not always going to need the molar mass. You're only going to need it to convert from grams to moles and moles back to grams. But if you have a problem where everything's already in moles, you don't need to worry about the molar mass. So just pay attention to that in your practice problems, and please let me know if you have any questions.